So I am, yes, talking about DDD and Entity Framework Core and microservices. And a lot of people ask, well, how do you use efCore with microservices? Which to me isn't really a very interesting question because it's just using efCore. What's interesting is about designing the microservices correctly or in an intelligent way, and then once you've done that, then how are we going to implement efCore? And my go-to when I'm thinking about architecting microservices is the lessons that I've learned from domain-driven design over a lot of years. So that's what I want to walk through here. Just make sure you understand this connection between microservices and domain-driven design, and then once you've implemented using DDD ideas, how Entity Framework Core helps when it comes to doing the mapping and persisting the data. And I'm just wondering why my screen isn't moving. Okay. So microservices and domain-driven design have a lot of guidance in common. So it's all about, breaking up your monolith or breaking down these big complicated problems that you're trying to solve with the software that you're writing. Once you've broken them apart, then it's also important to create boundaries around the different parts. So whether that part is microservice or we're talking about DDD bounded context, or creating really kind of impermeable boundaries around them. And that's important because as you're solving the problems in one bounded context or microservice, the problems that you're solving there don't leak into another one and then make it harder to solve the problems of the other microservice because there's all this extra unneeded complexity in the way. Another bit of common guidance is in, I would say, a perfect world where you've got large teams, to have these microservices or bounded context developed in isolation and have different teams working on them so that they're really focused on them. And then another really important piece of guidance that's common between them is having a unique database for each microservice would have its own data store, not necessarily database, right? Just some way of persisting data. But they don't need to be intermingling. They just are independent. So they're really all created in isolation, right down to how the data is persisted. So once we've laid out some of these common guidance, then come the questions. And we've got a lot of the same questions as well. How do we figure out how to break these problems up into smaller problems? How do we figure out where those boundaries are? What do we do when we've got data that overlaps or types that overlap between services or bounded contexts? Here's one that creates a lot of stress for a lot of people. What about relationships that cross boundaries? And then once you've defined all this, how do you communicate across those boundaries? So fortunately, domain-driven design has been around since 2003 when Eric Evans wrote what we call the Blue Book, Domain-Driven Design, Tackling Complexity in the Heart of Software. 17 years. So there's been a lot of really great thinking and experience that's gone into how to really take advantage of the guidance of domain-driven design, which we can then apply when we're thinking about designing microservices. So I don't want to be presumptuous that people do have understanding of domain-driven design. So I'm going to do the quickest overview of my life of domain-driven design, because I think you need context so that you understand why I'm doing things the way I'm doing them, once we start looking at the code and getting into efCore. So domain-driven design, it's right in the name. We're not bearing the lead. The focus there is on the domain. So like thinking about efCore and data persistence, right? We're not worrying about how efCore is going to do its job and how the data persistence is working. You really want to focus on the problems of the business. Another really important piece of domain-driven design, just kind of an overarching theme, is about collaborating with the domain experts. They're the ones who know the domain, what the problems are, what they need to solve, right? And so it's a collaboration between the technical experts and the domain experts, not just up front, but pretty far through. When we're actually following domain-driven design, really breaks down into two different areas. One is strategic design, and the other is tactical design. And I do happen to focus a lot on the tactical because I talk about how entity framework comes into play. But I want to, again, just give you an overview of what these are. So strategic design is about analyzing the problem and modeling the business problem. So it's identifying these subdomains, breaking the problem apart, figuring out which of those subdomains is really your core domain. This is your moneymaker, what really sets you apart, because that's where you need to really have your laser focus. That's the most important thing. Some of the domains are still important to your business and kind of unique, and these can be supporting domains. And then it's also really important to be able to identify generic domains. This is stuff that maybe you don't need to waste your time figuring out, architecting and implementing, like third-party services that you can take advantage and then connect to. And then as you're doing this, you're also identifying the bounded context. They don't necessarily align one-to-one with a subdomain, but they're usually pretty close. And then the last big piece, there's a lot to it. DDD is a big topic, but the last big piece of strategic design is planning how all of these different subdomains and bounded contexts are going to connect with each other or even through some other service to make a connection to each other. I'm pointing to my screen. I always have to wave my hands for some reason. So before I go further, and this is a huge topic, and I just want to make sure you're aware of it, is that when I'm talking about DDD and bounded context and microservices, a lot of people make an assumption that a bounded context and a microservice are one and the same, that the boundaries around a bounded context equate the boundaries around a microservice. And in some cases, in a lot of cases, that might be true, but there are definitely cases where that just doesn't make sense. You might have a number of microservices within a defined bounded context, or for some strange reason, the other way around. So there's a lot of good information out there about that. I just want to get that into your head so that you don't make that leap, because a lot of people do. So once you've done your strategic design in 2 minutes or less, then it's time to get going on the actual implementation, which is the tactical design. And this is designing what's happening inside each bounded context. So the really critical concept here is that you're going to be working with an aggregate. You're defining aggregates. An aggregate is essentially a transactional unit of different entities that work together. And every aggregate has an aggregate route. This is really, really important. An aggregate route is in charge of what happens with everything else within the aggregate. So it's got all the rules for invariance and validation, et cetera, related to the various entities, properties, value objects that are within the aggregate. So that's really important. And as we get into tactical design, we're getting closer to where efCore comes into play. So just to not be so generic about this, just a really good canonical example is if you have an order has line items, and line items really don't make sense on their own. They only really make sense within an order, and the order as an aggregate route can make determinations like you can't have more than $100 spent total, right? So it knows about all the line items. And we also have value objects, and I could spend quite a bit of time making sure people understand value objects. You can go find other talks or articles or writing that I've done about that, but I just want to make sure you're aware that value objects are different than entities. They're a different kind of a type, and you'll see some in the code that I'm going to be showing. So when we're designing aggregates, this is important, right? Because this is where the idea of, if we don't care about data persistence, then how is the data going to get persisted, right? So what is it that we do care about? What we care about is that you're designing your models based on the needs of the business, the problems you're trying to solve. And it's probably an old joke coming from me now, unless you're designing the next OneDrive or the next Dropbox, data persistence is probably not your core domain. So that's not your business problem. An aggregate route, as I said, it maintains the invariants and rules inside of the whole aggregate. The entities, when you design your entities, these aren't DTOs, right? We have rich behavior. They're really focused on behavior. When they're really just getters and setters, we refer to that as an anemic data model. And that's not a bad thing, but that has its place, right? And domain-driven design also has its place. Some of the helpful patterns that we use, for example, is to protect properties. We use a lot of encapsulation. I like to refer to it as ADD-driven design, because I'm such a control freak. So you really protect your properties to make sure that nobody who's using your class can do things that you don't want them to do. They can't have effect on them that you don't want. And another important thing is to look for value objects. Again, this will depend on an understanding of them, but once you do, they're a really important part of the aggregate of your system. And just a little hint about them is quite often when you think something's a one-to-one relationship, it's much more likely that it could be better represented and handled as a value object. And there's plenty of other things about designing aggregates. And also, there are things that while you're focusing on your aggregates, you just say, I'm not going to worry about that right now. And we have patterns in DDD to take care of those. And I'll use those patterns when the time comes. I don't mean I'm going to today in my short time here. So, drilling in closer to where we're getting to entity framework. So domain-driven design, one of the big tenets of domain-driven design is to ignore data persistence, right? And we can. We're, focusing on our data model, not letting the problems of persisting the data or the problems of how your database schema needs to be or anything about the database. Like, just don't worry about that when you're creating your domain model. And what's nice is Entity Framework Core, and I'm not saying 100% of the time, right? But it is so rich now in terms of what it can do to help us map our nice domain models and create a data model with the DB context, like all the configurations and everything, create an in-memory data model and create that data model to closer represent how it can be persisted into the database and come back out. So that's an interesting thing. You can have an extra data model and have a mapper, or where Entity Framework will solve a lot of these problems of doing that transformation. We can use Entity Framework Core to define that data model that will allow us to take our domain model and make sure it gets persisted into the database. So thanks to a lot of wonderful features in efCore, and we get more and more features that enable us to do these kind of mappings as each iteration of efCore comes out. So what I want to be able to do is show you a number of different features. that allow me to take my nicely designed domain model and still be able to map them into the database. So we've got private field or private property support, we've got field mappings, we've got support for encapsulated collections, we've got a feature called owned entities, which lets us map value objects. We've got shadow properties, which are great for keeping track of kind of audit data that you don't want in your domain model. We've got value converters, so you can use .NET types, and they know how to persist the data. Keyless entities, new. And also, for those of you who have been waiting and waiting and waiting for many-to-many mappings, we're going to be getting them in efCore 5. Up until now in efCore, we've had to do those explicitly. So flip over here to Visual Studio. All right, so, actually, just so you know what I'm working with, so the aggregate route that I have is about team management. So I have a team management bounded context, and my aggregate is about managing the team. So I have a team entity, has a bunch of properties, team name, nickname, you're found at home stadium. So those are just scalar properties. Then I have a value object called uniform colors. And then I have a collection of players. And players have the player type has a property called name that itself is a value object. And I also have a one-to-one relationship between team and manager, since the team only has one manager at a time. And the manager also takes advantage of this value object called name. So what does this look like? So here's my team class. First of all, trying to do a little bit of nicely designed projects here, right? I got entity framework is outside of all of my business logic. And, it's separate, right? It has nothing to do with my business logic. So I can design all of my domain models and testing and doing all of that before even worrying about persistence, right? But now the question is, how is this stuff going to get persisted? How can I be sure if I design it beautifully according to all the nice things I've learned from DDD, and then it's time to persist the data? I don't want any surprises. I spend a lot of time actually researching as each version of EF comes out to see where we're at and what more we can do. So this, a lot of what's going on here, again, is protecting this aggregate from anybody doing anything to it that I don't want them to do. So when I'm instantiating, I have to pass in the team name, nickname, you're found in home stadium, right? And so that's the only way, these are the business rules. These are the rules that I determined, right? A team doesn't make sense unless it has those things. So why create a team that doesn't have those properties filled? So notice that this constructor, the parameterless constructor, is private, so nobody can just go ahead and instantiate a team with no team name or nickname in it. We need those things. Also, when I'm doing that, I'm also instantiating some of the other properties. So here is one thing you'll notice throughout this whole class is there are, except for these properties here, which are just kind of extraneous to this example. So they have getters, but I don't really care about those scalar properties, right? So all of the other properties that I want to protect, there are no getters here at all. So right off the bat, the key property, ID, I'm using an expression body to populate it, and I'm keeping track of that ID with this variable. And notice also, not only is the field private, which is normal, but the property's private also. Nobody needs to be reading the ID, right? So from outside, when they're looking at team, nobody needs to be looking at that, except Entity Framework will. And Entity Framework, so Entity Framework is able to see properties that have either a getter or a setter, but this has an expression body. So I've really messed this up as far as Entity Framework is concerned, but I've designed it the way I want to because I wanted to protect things. So here's the context, the DB context, and what I've done is because this doesn't even have a getter or a setter, by default, Entity Framework won't recognize it. If it did, it would realize this is here, it would realize it's the key, it would understand that we've got this backing field here. But because I've encapsulated it even further, it's not going to see it. But all I have to do is come in here and say, oh, by the way, that ID property, that's the key property. And now it'll be happy. And it'll also recognize the underscore ID as the backing field. And by default, starting with efCore 3, Entity Framework will actually, if it recognizes a backing field is tied to a property, it will automatically use that backing field when it's reading for saved changes and also when it's materializing objects. It'll actually materialize the field instead of materializing the property. So the next thing I'm doing is encapsulating the team name. Now, my business logic for doing this is because I wanted to demonstrate another bit of mapping here. So, this is really protected. Nobody can touch team name. And, again, I'm using the expression body here. So this is a little different than with a GUID because here at least the property is public because I do want people to see what the team name is. But because I don't have a getter, it's still, if this just had a getter, then Entity Framework would figure it all out. But again, I'm protecting it even more using DDD or maybe ADDDD. So I can go in here to the DB context and just add a mapping. So one of the things I want to make sure you understand is I don't need you to memorize all of these mappings and properties. My bigger point is I'm designing this aggregate the way that I want to in a really constrained way and protecting everything. But Entity Framework is giving me all kinds of great configurations that I can get around and still be able to map things without having to worry about that. So in this case, I needed to explicitly let Entity Framework know about that field that's called team name. And the reason I'm doing it as a magic string here is because the field's private, so I can't use a lambda. So here's another example of encapsulation that is a pattern that we've often used with domain-driven design, but has always been had with up through EF6, had always been a big challenge to deal with persisting with Entity Framework. There was really no way to do it. And it was really frustrating because we found ourselves modifying how we designed our aggregate to accommodate for Entity Framework. So what I'm doing here is I have a collection of player objects, right? I'm not exposing the collection. And notice this is a field anyway. So the player's property is an IEnumerable. So people can access the players and they can read that players, but they can only enumerate through it. They can't add players to it and they can't remove players from it. However, as they're enumerating through it, they could grab a player and edit it. So what I'm doing is using a defensive copy, and I'm returning a copy of it by calling toList. So people are not working with the actual player, so they can't edit the player. So it's totally protected. Now, internally, I've got the players collection. That's where I can work with it. And then remember, I said an important thing about defining your aggregate is that we do it based on behaviors, not just DTOs, right? Not setting and getting properties. So if you want to add a player, I've got some rules that have to be applied. I have some specific logic. So I've got this add player method. And what this does is just make sure that a player isn't already added to the roster. So we're just protecting it from that. And then so it's totally protected. And I'm trying to remember off the top of my head if Entity Framework is going to recognize this. I don't even have to add an extra configuration for this. And the other interesting thing is the difference from efCore 1 and 2 to efCore 3 was before efCore 3, materialization would have gone through here, but now it's going to go through this backing field. Another interesting thing I'm doing in here is the manager. So the manager is a one-to-one relationship, actually a 0 or 1, right? Because a manager could get fired and not be associated with a team. And again, I'm doing all of this protection here. There's actually no manager property, right? All I have here is the field. I don't have the actual property. And then if somebody wants to see the manager name, they have access to it. So if I want to modify a manager, I have to use a behavior. I have to go through this function, pass in the new manager, and then the manager class has some logic that says, oh, if we've already got a manager, then obviously we got to fire that manager before we can create this person as the manager, and we get some history happening there. So this, again, because there's a lot of scenarios in which Entity Framework would figure things out, but I'm actually have constrained this so much that I needed to give Entity Framework a little help here. So if I go back to the context, where is it? Down here, I have a configuration to make sure that Entity Framework understands that that field, right? Because there's no property now for the map for doing the linking, right? But I can still use has one with the field that represents that relationship. And another interesting thing I'm doing here, this is actually not, this has been around since EF1, I think, is that the foreign key inside of manager is not named by convention, so I have to explicitly tell that. The other interesting thing here, and it took me a little bit to figure this out because I was like, what's going on here? Because I wanted that manager to possibly be independent, orphaned from a team if they're not managing a team quite yet. I needed to use this mapping to make sure that that was possible, because if we look in manager, we'll see that that foreign key is a nullable GUID. So let's see. So by the way, I'm not going to run them every single time. I have lots and lots of tests here to make sure all of these assumptions I'm making, all of the things I'm doing are working. So I've got a whole bunch of class tests for my domain classes just to make sure that internal logic is working. But I've also created a slew of in-memory tests with Entity Framework Core, and also some integration tests directly with the database, because there's a lot of things that in-memory is still not going to represent when it comes to actually testing a database. So it's really important to do that. There's a couple of other things I want to show you that are, my beautiful entity domain-driven design design. So for example, value objects. I said I've got some value objects here. So person full name is one of them. Sure, I could have a first name and a last name inside a team and inside of, inside a player, inside of manager, but I've got a bunch of logic that I want to always have around somebody's name. Not only do I want to have a first and last name, but maybe I want to be able to expose it as the full name, like first name and last name, or maybe I want to have last name, comma, first name. So I can encapsulate that in here. And so that's a complex type. That's really all that is. But there's a few more things that make this a value object. One is that it's immutable. So the only way to set those first and last name values are when you're instantiating that. And also, these are really important pieces of a value object, facets of a value object. You have to be sure to override the equals and to get hash code for equality comparison, because it needs to compare all of the values. And the other important thing is there's no ID, no key value. Okay, so this can only be used as a property of an entity. And these are the pieces that make this a value object, the get hash code and the equals. But without those, that still aligns to the definition of an efCore owned entity. that it's immutable, that it has no ID. So, and that it's used as a property of another entity. So the only thing is efCore can't infer that, can't figure that out. So you have to explicitly map that. And that's what I'm doing here. I'm saying the player entity owns one, so it's an owned entity, and its property called name factory represents that owned entity. And then manager also has a property that is one of those owned entities. And in fact, the team has its own value object, or has a property that is a value object, which is these uniform colors. And I'm also specifying that the team owns one of the uniform colors. And while I'm doing that, I'm also doing something pretty cool. If you've ever tried to persist the color struct of a with Entity Framework into a database, you can't do it. We have to go through all this crazy stuff to turn it into text and then read it as text and turn it back into a color. So there's a feature called value conversions, and this has conversion property is one of the ways of expressing value conversion. So this is kind of an on-the-fly way. And this just says, so if we're looking at that primary property, which is a color struct inside of my uniform colors, right? So if we're persisting, if we're sending to the database, then use the name property of the color struct to get the text, and then you're going to store the text. And when you're reading it back out, you're reading text, and what we're going to do is use the color structs from name method to convert it back into a color struct. So these are all kinds of ways that I'm achieving being able to use Entity Framework core, like sticking it in after the fact, after I've designed everything the way I want it based on domain-driven design. And then Entity Framework core is able to handle these. There's all kinds of other examples. So for example, these shadow properties, I'm creating properties that exist only in the data model. They don't exist in my team class, my entity class. So I've got created and last modified as audit properties that I want stored in the database so that I can do reporting on them. So now I don't have to add that into my business logic. And in fact, during save changes is when I'm specifying the values, what the values of those should be as I'm about to do the save changes. So that is a lot. And as quick as I could do it, and I think I'm getting close to running out of time, or maybe I already have. And so do we have time for questions, or did I use up my whole 30 minutes?
You went a little bit over.
Me? What?
Yes.
Me?
But we have a lot of questions out on Twitter.
I'm good on Twitter. I certainly want James to get going.
Perfect. So I was going to say, if you look at the .NET Conf hashtag, you can
Yeah.
find all the questions, and some of them you're tagged with. So thank you, Julie. This was
Awesome.
really, really great.
Thanks so much.
You did amazing.
All right. Have fun, James. Good to see you. Bye-bye.
Bye. Thank you so much. Everybody, we'll be right back more with James Newton King talking about gRPC on .NET Conf, focus on microservices. We'll be right back.